Okay, here's our video for 12-6 Part 2, solving quadratics by taking the square root of both sides. Okay, so when you're solving using radicals, this is a quadratic because it does have a squared in it. And so we have a quadratic, we have an A term, we have a C term, and you notice we're not setting them equal to 0. Okay, we're having the A term on one side, the C term on the other, and there's no B term. So this is a strategy that works when there's no B term. So you're going to take the square root of both sides, and you're going to make sure you answer with a plus minus symbol in front of your answer. Now, on your homework, you're going to want to read directions to find out if it wants the radical answer or the decimal answer or form. Okay, so n squared equals 25. You're going to just take the square root of both sides. And 25 is nice because it's a perfect square. So n just equals plus or minus 5. Okay. In my second example, we're going to do this one as radical form. So we're going to take the square root of both sides, but we're going to simplify this as, simplify the 72 and keep it in radical form instead of a decimal. Now remember, 72, when I'm trying to find the largest perfect square that comes out of 72. So 9 is tempting because 9 times 8 is 72. However, 9 is not the largest perfect square that can come out of 72. 36 is the largest perfect square that can come out of 72. So 36 times 2. And so that means that x equals square root of 36 is 6, so plus or minus the square root of 6, or plus or minus 6 root 2. Okay, I'm going to do the third one in decimal form for two reasons. Number one, 41 does not divide and simplify. And if it doesn't simplify, then a decimal form is really the only choice that we have. Okay. Again, I want to reiterate on your homework, read the directions. That'll tell you whether you should be answering in simplified form, simplified radical form, or decimal form. So square root of both sides, just do that on the calculator. You get n equals plus or minus the square root of 6.4. Remember, that's a rounded answer because the square root of 41 is a really long decimal. Okay, really quickly, this is not in your homework assignment, but what if x squared minus 40 equals 0? So we have our quadratic in standard form, and it's set equal to 0, which was, when we were doing factoring, is how we were trained to do. However, if I have no b term, there's nothing x, then I can use the strategy of taking the square root of both sides. Once I add 40 to both sides, okay, then I get x squared equals 40. And we can take the square root of both sides. X equals, let's see, let's break this up into root 4 times root 10. Okay, so 4 is the largest perfect square that I can pull out of 40. So my final answer would be x equals plus or minus 2 root 10. So there's none on your homework like this, but you could easily see something like this on your Regents or some other paper that is set up this way. Now, I also want to point out that this one, let's try that same thing again, except that's a plus 40. So we're going to minus 40 on each side. And I've got x squared equals negative 40. Okay, now if I take the square root of both sides, wait a minute. I cannot take the square root of a negative number. This would have no solution. solution. You cannot take the square root of any negative number. Okay, so we're building towards what we're going to be doing next week, which is completing the square. So this is a building block kind of equation to get to completing the square, which is a strategy we're going to learn next week. If I see an equation that's set up in this way, a binomial squared equaling another number, okay, I'm going to take the square root of both sides. And that feels strange because I'm taking the square root of an entire binomial pair. And what I get is m minus 2 equals, remember we have to do plus or minus 5. Okay, square root of 25 is 5. So we're going to solve twice using both the positive and negative square roots. So I'm going to break this into two pieces. I'm going to do m minus 2 equals positive 5 and add 2 to both sides, solving like I normally would. And m equals 7. That's one of my solutions. Then I'm going to take my m minus 2 and set it equal to negative 5. Still adding 2 to both sides. And I'm going to get negative 3 as an answer. So my two solutions are 7 and negative 3. But I had to do that 2 times. Okay? 2n plus 3 squared equals 49. Same thing. Okay, I'm going to square root both sides. Okay, and 2n plus 3, too much, equals plus or minus negative 7. So 40 squared root of 49 is 7. Then I'm going to again break this into two parts. 2n plus 3 equals positive 7. And 2n plus 3 equals negative 7. Now these are just two steps. Subtract 3 both sides. So 2n equals 4. Divide both sides by 2. And n equals 2. So that's one of my solutions. 2n plus 3 equals negative 7. So I'll subtract 3 both sides. 2n equals a negative 10. Divide by 2. And n equals negative 5. And that's my other solution to that. Okay, so looking at sections 15 and onward in your homework in 12.6, they sometimes get a little crazy showing the work here. Okay, so they write a lot of steps, like right in here they're kind of guessing. They're making up what could possibly be the decimal square root of 40. And they guess 6.3 and 6.4 and then ultimately decide it's 6.3. Well, we have a calculator and we're going to use it. So what you're going to write for each problem in the 15 through whatever section is you have the problem, you'll square root both sides, and you'll give your answer. The 15 section is giving answers as a decimal. So you'll round to the nearest tenth is what the directions say. The squiggly equal indicates that you rounded, and don't forget to put plus or minus. Okay? So that's what you really have to do for the homework there. The next section on your homework is asking you to do the exact same thing, except instead of answering in decimal form, they want an answer in radical form. Again, I think they kind of go a little crazy showing work here. Original problem, show square root both sides. It's a critical step. You have to show it. Okay, x equals plus or minus square root of 48. I don't even think that's terribly necessary. X equals plus or minus, we got square root of 16 and square root of 3. Remember, we're dividing out the largest perfect square that comes out of 48. And we get x equals either plus or minus 4 root 3. Okay, number 25 on the homework is a beast. So starts off pretty simple. Square root both sides. Okay, 8, not even that big of a number. So I get 12 minus x equals plus or minus 2 root 2. Okay, because the square root of 8 is going to be the square root of 4 times the square root of 2. And the square root of 4 is 2, and bring down the root 2. Okay, so that's how I get to there. Not too bad. Then we break it into our two pieces, like we have been doing. 12x equals a positive 2 root 2, and 12x equals a negative 2 root 2. Okay? Subtract 12, both sides. Here's where the first problem's going to come up. How do you do 2 root 2 minus 12? Can you really subtract that? And the answer is no, you cannot. One is a radical, one is not a radical, and you can't add and subtract things that are not radicals. So what you have to do is bring down your negative x equals negative 12 plus 2 root 2. So I cannot add those together or subtract them or anything. I can't do anything with them. I have to just leave it like that. Oh, wait a minute. The x is negative, so that's really not even my final answer yet. I have to factor out the negative from everything because I can't have a negative x. I need a positive x. So remember that factoring a negative sign out just changes all the signs. So it'll be a positive x equals a positive 12 minus a 2 root 2. And that whole thing is one of my solutions. Huge pain. Okay? Now we have to do all that again, but this time setting it equal to negative 2 root 2. So subtracting 12 both sides. And bring down negative x. Now again, I can't actually subtract that. I'm writing the whole number term first and the radical term second, although truthfully I don't think it matters. But then here again, I've got a negative x. I can't have a negative x. I got to factor that out. So it becomes positive x equals positive 12 plus 2 root 2. And that is my other solution. So it is a real pain to do radical form with this sort of equation. It's definitely easier to do with the decimals, but at least I got this hard one out of the way for you right here in the video. Okay, have a great day. Enjoy your weekend, and happy April Fool's Day. There's no April Fool in my video, but I hope that you weren't pranked terribly today. Have a great weekend.